Web, that on page 401 to 402, you're gonna do problems 1 through 15, all of them, but then there's some word problems from 16 to 20, you can pick the 3 that you like and do those 3. So, problem solving. Now we've already been over sine and cosine, and we talked about how right angles have all these properties, and we talked about the Pythagorean theorem. So we're just going to keep working a little bit more in depth with those values, okay? So if you have any trigonometric ratio, which means if you have a sine, a cosine, or a tangent, if you know that value, then you're able to find, and you have an angle, you're able to find lengths of sides or other angles. So once you have the sine or the cosine or the tangent value, it can help you find the rest of the information that you need for that triangle, okay? And if you, so finding if you have the sine and you're trying to find the angle that has that sine, what you're actually finding is the arcsine. Same thing if you have a cosine and you're trying to find the angle that has that cosine, you're trying to find the arccosine. It's just a fancy name for the inverse of the sine or the inverse of the cosine. On your calculator, they are going to appear like this. It's going to say or cosine or tangent. Okay, arcsine, arccosine, arctangent. And you can enter that into your calculator. And it's going to be, basically you're doing the reverse of what you're doing when you have an angle and you're finding the sine. You have the sine and you're finding the angle. Okay, so for example, problem 1, again, I don't have my calculator, so I'm not going to do these, but you guys can easily. It says find the angle whose sine is 4/7. So if you want to go plug that into your calculator, you still have the tables in the back. If your calculator is not working, or if you're trying not to use your calculator because you're spending too much time on electronics, on the back there's not arcsine, so you're going to have to use your calculator, sorry. If you just go into your calculator and you just plug in, so what they're saying is the sine of whatever angle is 4/7, right? So it's just like an equation, we just have to find what x is. How do we find that? Well, on this side we divide by sine kind of, which means we're just taking the inverse sine. So we can say x equals arcsine or inverse sine or whatever you want to call it, oops, -1, of 4/7. So you go into your calculator, you press that sine -1 button, hit 4/7, or do the math and divide 4/7 and enter that, but you're going to get a value, and you're going to get 34 degrees 51 minutes. And I'm sure, depending on your calculator, it might give you something different. Honestly, if you want to round to the nearest degree, if you want to call that 35 degrees, I'm fine with that. But if your calculator gives you that answer, go ahead and put it in. Right? So that's pretty easy. Now, another thing that we're going to be doing is solving a triangle. Solving a triangle just means you're giving me all the values of that triangle. You're telling me the length of every single side, and you're telling me how many degrees each of the angles are. You know one of them is 90, but you're going to tell me the length of that measure of the other 2 angles. Now, in order to do that, you have to have at least one angle and one side, or 2 sides, sorry. You have to have 2 angles and one side, or 2 sides and 1 angle. You can find the whole rest of the triangle. So, in example 2, for example, you have 2 sides, no angles, except the 90-degree one. And we're going to find all the values of this triangle. Let's see what we can do. So we have a little triangle, and again, don't assume that any triangles that I'm drawing are to scale. So unless I actually tell you something measures something, don't assume that. If I do that, right now I'm telling you that's a 90-degree angle, so now you know that. Now we're going to call the triangle A, B's right here, C's right here. And all the information we have, aside from the fact that that's a 90-degree angle, is that this side is length 7 and this side is length 4. And you need to give me this side, this angle, and this angle. So that's quite a bit of information, right? So what could we do? We could say we have opposite over adjacent for this, right? So remember SOHCAHTOA? There's opposite over adjacent, right? So that's tangent. So we could do inverse tangent. But we could also just use the Pythagorean theorem and come up with C real quick, and then we don't even have to use any of these inverses, right? So what's the Pythagorean theorem? It's a squared plus b squared equals c squared. We're missing c squared, and we have a squared and b squared, or a squared and b squared, however you like to do it. As you know, I like to have the smaller number as a. So what's 4 squared, Alicia? 4 times 4.
16.
And 7 times 7.
49.
Yep, so this is going to be 16 plus 49 equals c squared. What's 16 plus 49? What's 16 plus 49? Alicia? 16 plus 49.
Why do you always ask me?
What's 16 plus 49?
57? No, 55.
65. And we have the book to tell us that it is in fact 65. We know that 65 doesn't have a square root. We could try to put it into smaller numbers, but the book didn't, so let's not. So we know that the length, I keep trying to find markers that are working, of this one is square root of 65. Right, that one doesn't work either. This guy. Right, because then you get, cross that out, make that a square root. So square root of 65. Now we have all the values, which means we can figure out what the sine is, what the cosine is, what the tangent is, which means that we can figure out what the angles are. So let's start with angle B. We can do the arc sine, right? Because we have opposite and we have hypotenuse. So we know that the sine of B is opposite over hypotenuse. Now again, if this was a final answer, you wouldn't leave the square root of 65 in there, right? Because you don't like square roots of 65, but we're just using it for a calculation. So you're going to say arc sine equals our angle. Now I don't have my calculator here. You guys should have one at home. You can plug that in, and let's see what the book says we get. Angle B is, so I'm trying to find it. Blah, 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 blah. Angle B is 60 degrees and 15 minutes. Which you should have gotten on your calculator. And again, you can do these in lots of different orders. Like I'm just noticing the book did it. Use tangent first. So it just depends on what you like. No matter, it's kind of like the simplifying at the beginning or the end, you will get the same answer no matter how you do it. So we figured out that this angle, I'm just going to say 60, is 60 degrees. So honestly, we don't really need to do the math because we know that the angles all add up to 90. So we know this is going to be 30, right? But if you'd forgotten, or if you were just having fun learning how to do stuff on the calculator and you want to practice, we could do for angle A, we have adjacent or opposite, and we have hypotenuse. Since we already did sine, let's do cosine. So we'll say cosine of A is, now cosine, remember, is adjacent over hypotenuse, so we're going to get 7 over square root of 65. And then we're going to get which is, I'm just going to cheat and look at the book, and it should be somewhere close to 30, 29 and 45. 29 degrees, 45 minutes. So we're just going to call that 30 degrees. So now you've solved the triangle. You have every single length and every single angle. So that triangle is solved. That's what it means by solve a triangle. Okay? Now, other types of problems that we're going to have, these are real world problems, right? Because why are we learning geometry? Theoretically, we're going to use it in the real world. So there's a couple of instances where we use it in the real world, which is angle of elevation and angle of depression. And really all we're doing is turning some type of real world situation into a triangle so that we can figure out measurements. So they give you a little example. I guess I'm going to draw it. I'll draw a little tower here. And then you have a person here. And then we have a tree here, right? All right, so, and we're gonna have another person up here. So what we're trying to figure out is what's this person's line of sight, right? This person's line of sight is that, which is kind of a hypotenuse if you look at it like a triangle, right? And then we also want to know the angle of elevation, which is this person's elevation compared to this one, which is that angle. Now we could just turn this into a triangle, right? If I know the distance this person is from this rig, and I know how high up that rig is, I can figure everything out. So this is your angle of elevation, and this is your line of sight. Now if you have the opposite, and this person's looking down at this tree, basically the same thing. Line of sight is still the hypotenuse, but since you're going down and your triangle is flipped, this angle is actually called angle of depression. So you'll see that in some problems, but it's basically if you're trying to figure out how far this person can see, or how far this person can see, or what the angle of depression is, or how elevated this person is compared to this one, you just make triangles out of the situation. So let's look at an example where they do that. And I'm going to erase this so I can draw some pictures. I'm going to leave the SOHCAHTOA up there in case we need it. All right, so, and they draw something for you in the book, which is helpful. When you guys are doing the problems, you're going to have to make your own little pictures. But we're going to look at example 3 on page 401, and it says an engineer sets up a transit, some type of surveying instrument. It doesn't matter, but we're going to draw a little person here. There's my engineer, and he has an instrument which looks like it's on a tripod and has some type of camera. Okay, so he sets it up in a convenient spot and measures the distance to the base of a building. So there's this building over here. Okay, and it tells you that this distance from where he's standing to here is 75 feet. And then it says the angle of elevation of the top of the building is 67 degrees. So that's the top of the building. And the angle of elevation, we're going to do it from where he is, right? Because that's the measurement instrument. And that is 67 degrees. So actually, let's say this distance is only to here. And then they want to know, find the height of the building. Okay, now we're going to assume the transit is 5 feet high. So we're going to assume that this distance right here is 5 feet. So where's our triangle? It's right here. What do we have? Well, we have that this is a 90-degree angle. We have that this is 75 feet. We have that that's 67. We don't have that angle, we don't have that, and we don't have that. What are they asking for? Well, they want to know how tall the building is. So before we even start, remember that once we figure out how tall the building is, we're going to, well, how long that line is, we're going to have to add the 5 feet to it because our triangle starts here. It doesn't include those 5 feet. So let's just remember at the end that we got to add those to it. So now we have to figure out basically the length of this side. So how are we going to do it? Well, we have a side that's adjacent to 67 degrees. We have 67 degrees. We're trying to find opposite. Now remember, there is no cotangent. So we could go look it up in the back of the table, in the back of the book, and we'll just find us the value like that. If you don't have the book, if the table isn't working for you, well, we can find another value and we can find it that way. But I'm just going to do what the book did, okay? So we have opposite and we have adjacent, we have an angle. So we know that the tangent of this angle is x over 75. Okay? Oh, and actually you can do this on your calculator. You're going to plug in tangent 67 equals on your calculator, and you're going to get, I don't know because it doesn't tell me. Let me look it up in the back of my book. So if you're on your book, you're looking for tangent 67 degrees is on page 614, and it's on the right-hand side, about 2/3 of the way down. So I'm going to go to 67, and I'm going to go to tangent, and I get 0.4245. So I get 0.4245 equals x over 75. If you just did that in your calculator, you should be able to tell me that I'm right. Now what do? Bring this guy to here, multiply. Times 75 equals x. And again, I don't have my calculator, so I'm just going to take their word for it. It says that they got 176.7, which is let's see, twice of that. I might have written down the wrong tangent. Because that's not what I'm getting. Because this is less than half, times 75 would be somewhere less than 150, and they got 176. So let's go back to the table, check again. 67 tangent 0.4245. Okay, so either the book is wrong or I'm wrong. But I get somewhere less than 150. The book gets 176.5. When you guys do your math, somebody text me to let me know what answer they got. But remember, that is this length. And remember that you have to add that little measuring instrument that's 5 feet. So either way, you add 5 to here and you get something less than 155 feet. Or you add it to here and you get 181.5 feet. So somebody let me know which is the correct answer, and then we can always write them to tell them that they're wrong. Okay, example 4. You're gonna have to erase my beautiful drawing here. All right, example 4 on the same page says, Jeff wants to know the approximate distance across a certain part of the lake. So we're gonna draw a little lake. And he wants to know the distance from point A, let's just make that over here, to point B. We'll just make that over there. He measures the distance along the shore from A to C. So, just have to change the pond to make it look like theirs, okay? All right, C is right here. And he measures that distance, and he knows it's 33 paces, which he's saying is 100 feet. So let's say that is 100 feet. Now, he estimates this angle, so we're gonna draw a triangle, right? It's a terrible triangle, but we're gonna say that angle right there is 80 degrees. They want us to find the distance from A to B. Now in this case, they give us a drawing that shows 90 degrees right here, but you couldn't assume that otherwise. So we have an angle, and we want to know the distance. We know that little side right there, and we want to know that distance, right? So if we're drawing a right triangle, it looks kind of like that, okay? And we know that that's 80. We know that's our right angle, and we're trying to find this distance right here. So how are we going to find it? Well, we have an angle. Oh, we have 100 right here, which means we have that side is adjacent to that angle, right? So we have an angle and we have the adjacent. But we don't have the opposite. Opposite over adjacent is going to equal what? Opposite over adjacent. That's going to be tangent. So we can use the tangent to figure it out, right? We know that the tangent of 80 degrees is going to be opposite, which is x, over 100. Now, you guys can use your calculator. I can go to the back of the book. Hopefully this time we coincide. Now, in the back of the book, 80 degrees is on page 613 on the right-hand side, pretty close to the top. I'm going to go to tangent, and it's going to tell me 0.1763 equals x over 100. That one's pretty easy, right? You just times that by 100. So you get 1, 2, 3. 176.3 equals x. Well, they got a different answer. So again, I don't know if it's because they're getting the tangent that you're getting on your calculator is different, but tell me what you get. The book again gets 567, even though they do this exact same math. So let me check tangent again, just in case. 80 degrees. Tangent over here. And it says, oh, no, for 80 I have to use the bottom, sorry. So tangent of 80 is 5.671, which is what the book got, right? 5.671, so it was me. I wrote it down wrong. Right, times it by 100, 1, 2, you get 567.1 equals x. So, easy enough. And again, we could have found that lots of different ways. You can use sine, you can use cosine, you can use tangent, whichever one you like better. That's it. Your homework problems should be kind of like this. The first problems, 1 through 15, are just plugging in values and giving me the answer. You can use the table or you can use the calculator. And then problems 11 through 15, you're solving that triangle. So you're going to have certain information on a triangle. You're going to have to find all the other information. And then the last problems where you're going to select the 3 are going to be more like these 2 examples that we just did. You can use the table in the book. Make sure you use it correctly, not like I was using it. Or you can use your calculator, which is